My dear students, in this video I am going to discuss the properties of cumulative distributions. What are all the properties of cumulative distribution function? We know the definition of a cumulative distribution function. In the previous video I have defined the definition of that. That is, let x be a discrete random variable, capital X be a discrete random variable. The cumulative distributive function of capital X is defined by capital F of X. Cumulative distribution of the random variable capital X is F of X, capital F of X. Small f of X is probability mass function. Small f of X is called probability mass function, and that also we have defined in the previous video. And capital F of X is the cumulative distribution function. This is nothing but probability of X less than or equal to X. So certain stage up to that we have extended some X values. This is the example of cumulative distribution. We will extend this function from certain state P of X. Suppose this is less than X is P of X less than or equal to X. Inside a stage that is Xi is less than or equal to X for sigma f of Xi, where X belongs to real number R. X are real numbers. We from X less than Xi less than or equal to some X, f of Xi, sigma f of Xi is called capital F of X, cumulative distribution function we have defined. For example, the properties of that cumulative distribution function capital F of X is, first one, the cumulative distribution function capital F of X lies between 0 to 1. The value of the cumulative distribution function lies between 0 and 1 for all real values of X in R. And the second one, capital F of X is a real valued non-decreasing function. See, consider this example of a cumulative distribution function. Is less than, what is that? 0 to 1. Initial value, left side 0, right side 1. It lies between 0 to 1. Capital F of X lies between 0 to 1. In this example you can find. And also it is a non-decreasing, real valued non-decreasing function. That means it always going on increasing values. See, 1 by 36, 5 by 36, 15 by 36, 21 by 36, this is 36 by 36. 1 is nothing but 36 by 36. So it is a non-decreasing function. Okay. And capital F of X is a right continuous function. It is continuous on the right side. It is uniformly continuous on the right side. That is, limit extends to some constant a plus f of x equal to f of a. Capital F of x equal to capital F of a. It is a non-decreasing function. It is right continuous function also. And limit extends to minus infinity. Capital F of x is f of minus infinity. That is 0. Left side is for minus infinity. F of minus infinity is 0. Similarly, limit extends to plus infinity. Other side. Capital F of X is capital F of plus infinity, which is equal to 1. So, right side is plus infinity, F of X is 1. Left side for F of minus infinity is 0. So, lies between 0 and 1. So, this is an example for a cumulative distribution function. And it is a non-decreasing function. And it is continuously, right side continuous function. And so on. Okay. That's all. Now consider this problem. In the exercise given in your textbook, a random variable capital X has the following probability mass function. This is the probability mass function for a given random variable capital X. That is, X values are 1, 2, 3, 4, 5, and the probabilities for the corresponding X values f of X is k square, 2k square, 3k square, fourth value is 2k, and probability for 5 is 3k. If it is the probability mass function for the given random variable capital X, find the value of k. That's our first. Second question is probability of 2 less than or equal to x less than 5. And the third one is probability of 3 less than x. These things you have to find. We know that the sigma x less than or equal to xi f of xi equal to 1. See, for a probability mass function, sum of all the probabilities are 1, you know, the condition for the probability mass function. For that, k square plus 2k square plus 3k square plus 2k plus 3k equal to 1. By definition, k square plus 2k square plus 3k square plus 2k plus 3k equal to 1. That is 3 plus 2, 6k square plus 5k minus, you bring this one to the left hand side, it is minus 1 equal to 0. Now you factorize this equation to find the value of k, that is 6k square plus 6k minus k, 6 minus 1, 5k, 6 into minus plus minus 6k square. So you can take 6k of common, k plus 1. Minus 1 common, you will get k plus 1. On factorization principle, you will get 6k minus 1 into k plus 1 are the factors for this equation. From this implies 6k minus 1 equal to 0 implies k equal to 1 by 6. 6k equal to 1, k equal to 1 by 6. And k plus 1 equal to 0 implies k equal to minus 1. Which is not possible. This is wrong because k should not be negative. Probability should not be negative. So f of x is not negative. Not f of x is always greater than 0. Therefore, k equal to minus 1 is not possible. F of x probability should always positive. Therefore, k value is 1 by 6. So first answer for the problem k equal to 1 by 6. So that this mass function, therefore probability mass function become x equal to 1, 2, 3, 4, 5 and f of x is k square. K square is 1 by 36. K square. K is 1 by 6. K square is 1 by 36. 2k square. 2 by 36. 3k square. 3 by 36. 2k. 2 into 1 by 6. That is 2 by 6. 3k. 3 into 1 by 6 is 3 by 6. This is the required probability mass function. After finding the k value, we will get this. This is the probability mass function for the given problem. Okay, our second question is probability of x, that is 2 less than or equal to x less than 5. That means probability x greater than or equal to 2 and less than 5. Equal to 2 and less than 5. That is probability of x equal to 2 plus probability of x equal to 3 plus probability of x equal to 4 only, because it should be less than 5 but greater than or equal to 2. X is equal to 2 and less than 5. P of x equal to 2 by 36 plus P of x equal to 3 by 36 plus P of x equal to 4 2 by 6. So on taking LCM 36, you will get 2 plus 3 plus 6 6 are 36, 6 is 12. So 12 plus 3, 15 plus 2, 17 by 36. That is the answer for this problem. Probability of 2 less than or less than 5 is 17 by 36. Third one is probability of 3 less than x. Probability of 3 less than x means it can be expressed as probability of x greater than 3. You can write this as probability of 3 less than x. Instead of that, it is x greater than 3. X greater than 3 is 3 plus 4 and 5. That is probability of x equal to 4 plus probability of x equal to 5. Greater than 3 means you have to consider 3 and 4. 4 and 5. That is, this is 2 by 6 plus 3 by 6. So that is 3 plus 2, 5 by 6. So probability of 3 less than x is 5 by 6 and second problem is 17 by 36. So that's all about the problem. Okay? See this problem. Another problem. Here cumulative distribution function is given. In the previous problem, probability mass function is given and they ask you to find out the probability distribution function. But in this problem, cumulative distribution function capital F of x is given and they ask you to find out the probability mass function. Small f of x you have to find. Capital F of x given, small f of x you have to find. So what is the procedure for finding the capital F of x? Just you are adding the probabilities one by one successively, you will get cumulative distribution function. P of x equal to 0 plus P of x equal to 1, it gives you P of x equal to 1. And P of x equal to 1 plus P of x equal to 2, that gives you, you are adding one by one successively, you will get the probability mass function. Cumulative distribution function. To get the probability mass function, we have to subtract one from one by one. See, probability mass function, first term for x equal to 0, it is 1 by 2 itself. Okay. But probability of x equal to 1, small f of 1 is, what is that? F of x equal to 1 minus x equal to 0. We, have x equal, we want to find out f of 1. That is equal to capital F of 1 minus capital F of 0. Capital F of 1, that is 3 by 5 minus 1 by 2. You will get 3 by 5 minus 1 by 2. See, successfully you are adding for getting cumulative distribution function. From cumulative distribution function, you have to find out probability mass function, subtracting successively. For that f of 1 is 3 by 5 and minus f of 0 is 1 by 2. By taking LCM 10, 2 5s are 2 3s are 6, 5 2s are 5. So 6 minus 5, 1 by 10. So this is f of 1 is what? 1 by 10. So this term is 1 by 10. And then 4 by 5 to 3 by 5. We want to find out f of 2 next. F of 2 is capital F of 2 minus capital F of 1. What is capital F of 2? 4 by 5 minus 3 by 5. That is equal to 1 by 5. 4 minus 3, 1 by 5. So you will get 1 by 5. To adding these two, you will get this. Like that. Okay. 1 by 2, 1 by 10, 1 by 5. And f of 3, capital F of 3, you will get f of 3 you want. What is that? F of 3 minus f of 2. One, 9 by 10 minus 4 by 5. 9 by 10 minus 4 by 5. Here also by taking LCM you will get 9 1 is 9. 2 5 are 10, 2 4 are 8. 9 by 9 minus 8, 1 by 10. Again f of 3 is 1 by 10. And finally we want f of 4, that is capital F of 4, small f of 4 is f of 4 minus f of 3. That is we want f of 4 that is equal to f of 4 minus small f of, this is small, because probability mass function is small f of 4 is capital F 4 minus capital F of 3, that is 1 minus 9 by 10. 10 minus 1, 9. 10 minus 9, 1 by 10. So this is also 1 by 10. So these two gives you probability mass function. Therefore, first problem, the probability mass function is x is 0, 1, 2, 3, 4 and probability mass function capital F of x is small f of x is 1 by 2, 1 by 10, 1 by 2, 1 by 10, 1 by 5, 1 by 10 and 1 by 10. That's all. This is the first answer for the first subdivision. Probability mass function. Okay. Second question. Probability of x less than 3. Probability of x less than 3. That is less than 3 means 0, 1, 2. Probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 less than 3. X equal to 0 is 1 by 2 plus 1 by 10 plus 1 by 5. That is 10 LCM you are taking 5 plus 1 plus 2. 8 by 10. 8 by 10 simplification you will get 4 to 8, 5 to 5 to 4 by 5. So probability of x less than 3 is 4 by 5. That is the second problem. Probability of x less than 3 is 4 by 5. Okay. And third one, probability of x greater than or equal to 2. Next, probability of x greater than or equal to 2. Third one, probability of x greater than or equal to 2. Equal to 2. 2, 3, 4. Probability of x equal to 2. Probability of x equal to 3. Plus probability of x equal to 4. That's what we want. Probability of x equal to 2. 1 by 5. Plus x equal to 3. 1 by 10. Of x equal to 4 is also 1 by 10. By taking LCM 10. 2, 1, 1. 3 plus 4 by 10. On simplification is 2 by 5. 2 2s are 4, 5 is 2 by 5. So probability of third one, probability of x less than or equal to 2 is 2 by 5. Okay, probability of x greater than 3. Probability of x less than 3 is 4 by 5. Probability of x less than or equal to 2. Greater than or equal. So probability of x greater than or equal to 2 is 2 by 5. That's all about the problem. Okay. Thank you.